Hi, welcome to the chapter on hypothesis testing. Today we will be doing one of the questions. Now let's spend some time reading the question. Now in this question, Mr. Lee claims that the teenagers spend at least 14 hours on social media any weekends. Now, in this question, you realize that the population mean is not given. Population variance is also unknown. And in the question, it's not stated what kind of distribution it is. So the type of distribution is unknown. Now what other information we have? We are given there's a sample is being taken. The sample size is 15. And you are given the following values. Summation x is equals to 170. And summation x squared is equals to 245. Now we are supposed to test whether this claim is true or not. Now so first of all, from here, since mu and sigma is not given, we need to estimate the values of mu and sigma. So how do we estimate the value of mu and sigma? Now, mu can be estimated to be x bar, that is summation x over n, all right, the sample mean. And that is equals to 170 over 15. And you get a value of 11.33. Now, sigma is also not known. So we need to use the sample variance to estimate. The sample variance is the unbiased estimator of the population variance. And the sample variance is given by this formula. S is equals to, or S squared variance, n minus 1. Then you have summation x square minus summation x whole thing squared divided by n. Okay. So you put in the value. Now n is 15, so n minus 1 is 14. And you put in summation x squared is given as 245 minus summation x is 170 square over 15. All right, you can punch this into the calculator. And then what is the value of it? And then you do a square root. S will be equals to 5.4463. Now from this, we will know the distribution of x bar. But because we do not know the type of distribution, what is the kind of population, what kind of distribution is the population. So in this case, we are stuck by the limited information. So we assume, now we cannot use central limit theorem because n is only 15. Now so only way is we need to assume that this is normal. If this is normal and sigma is not known, so we can use the t distribution. Now, so we assume that population is normal. So what's the assumption? All right, the assumption we have to make is assume the population is normal. The population has a normal distribution. Normal distribution. All right. Now, with this assumption, then we go ahead to use the t distribution. Because the t distribution is based on a normal distribution. All right, the population distribution has to be normal in order for us to use a t distribution. So what is H naught and HT, the null and the alternative hypothesis? Now, from here, H naught will be mu is greater than or equals to 14, because Mr. Lee claimed that there's at least the teenagers spend at least 14 hours on social media. And what is H1? H1 is the alternative hypothesis. So the alternative hypothesis will be the opposite of H0, so it's less than 40. Now, so based on the assumption that H0 is true, okay, based on the assumption that the H0 is true, assume H0 is true. Right, then you find that your X bar follow the t distribution. So now there's two ways you can go about doing it. You can do using the p-value or the critical value. Now you can go into your GDC. All right, you go under the t-test, and then you key in your sigma and your mean and your degrees of freedom, stating the significance level, and then they will give you the p-value, the t statistics. Now, just for you to understand, I will show you how to find the t statistics without using the calculator and how it comes about. Now, so the t statistics is just like when you want to standardize a normal distribution. You want to convert a normal distribution to a standard normal distribution. Now it is just like the z, your z score here. Now, but you use a t. So it's x bar minus mu over s over root n. Now instead of mu is s, because we don't have the actual, no, instead of sigma we are using s because we do not know what is sigma. S is an estimator for sigma. Now you realize that this is not z because we are using a t distribution, because s is unknown. All right, so the graph is a little bit stretched for your t distribution. So we that's why the idea of degrees of freedom comes into play. All right, so the degrees of freedom will be n minus 1. So in this case, you have 14 degrees of freedom. So you just need to substitute your x bar. Your x bar is given by 11.3. So it's 11.33 minus your mu is 14, all right, because you're assuming that this is true. So minus 14 over s is 5.45 5.4463. 5.4463 over square root of 15. And what is your answer over here? You get minus 1.889. This is the t statistic. Now, do you need to do this calculation? No, you can get all this from your GDC. Now, your GDC will also show you your p-value. So, your GDC will show you your p-value and your t statistics. Now, under your GDC, you go under t-test. Now, under t-test, they will ask you for your mean. Your mean, in this case, you take 14 because we are assuming that the hypothesis is true. And then we need x bar. X bar is 11.33 in this case. This is under your GDC. Now, also you need your mean, your sample size, and also your sample variance. And then your calculator will give you the t statistics and also the p-value. All right, your t statistics in this case, we take it as minus 1.889. Now you key your calculator may be a bit different from this because rounding off error. Now, and then you have your p-value. Now your p-value, you will get 0.0399. Right. Now let's look at it graphically. What does all this represent? Now you have a significance level of 3%. So let's say this is your 3% significance. Now we are testing it to be less than 14. So it's a one-tail test, all right, a left tail test, all right. So this is 3% or this is 0.03. Or you can write this to be 3%. Now, what is your p-value? Your p-value represents the probability of obtaining the results that is more extreme than your sample, than x bar in this case, less than x bar. So now more extreme than this, all right. Now your this value is your x bar, but when converted to a t distribution, all right, it is actually this value, all right. So where is this value? Now more extreme than this is 0.0399. So this is roughly about 0.4. All right. So to obtain results more extreme than 11.33, the percentage is 4%, approximately 4%. So your 4% will be on the right. All right. So this part, the yellow one or the orangey yellow, this is 4%. Now, where is 11.33? Now, 11.33 is not here because this is your t distribution. All right, your t distribution. So your 11.33, we have transformed it to a t distribution. This is your x bar. We have transformed it onto a t distribution curve. All right, so it corresponds to minus 1.889. So this is your value here, minus 1.889. All right, so your t statistics correspond to your p-value. Now this is a significance level, this blue dotted line here. Then what corresponds to the blue dotted line? That one is your critical value All right, this is your critical value. Okay, now how are you going to find the critical value? Now your critical value you can find using your inverse t distribution. All right, you can do it from the GDC. All right, so maybe I just write it here. So you go to your inverse t distribution. All right, and over there you key in your significance level 0.03. All right, and your I think it's your degrees of freedom or your n. I'm not sure which one. All right, so if they ask you for n, you just key in 15. All right, if they ask you for degrees of freedom, you key in 14. If I'm not wrong, it's n. If I'm not wrong, okay, you can look at it. Okay, I can't remember. Now that is how you get your critical value. Now, for this critical value, all right, you key into your GC under your inverse t distribution, you will get it to be, this value is minus 2.046. Now let's us analyze it using the p-value. All right, so if you want to analyze it using the p-value, we will compare it with the significance level. Now, since your p-value is greater than your significance level, we do not reject the null hypothesis. That means there is insufficient evidence to show that the students spend less than 14 hours on a weekend on social media over the weekend. Okay, now if we look at the using the if we use a t statistics, then we say that since t, all right, the t statistics is greater, all right, or falls on the right hand side, all right, of the critical value, we do not reject the null hypothesis, and there is insufficient evidence to show that students spend less than 14 hours on social media over the weekend. Okay, for that we have come to the end of this question. Thank you very much.